Welcome back, friends. Today I am going to explain about test case design technique for white box testing. Let me recap what are the topics we have seen so far. We have seen fundamentals of software testing, software test lifecycle, and software test levels. Before starting today's session, I would like to introduce myself. My name is Ganesh Hegde, working as Senior Engineer in Kpro Solution Private Limited. Kpro is a leading provider in Datalake, cloud implementation, IoT, blockchain, analytics, machine learning, artificial intelligence, deep learning, and mobile application development. Today's agenda for session is statement coverage, edge or branch coverage, condition coverage, path coverage, and cyclomatic complexity. Let us see the first test case design technique, that is statement coverage. Statement coverage covers first set of control flow elements to be executed in the statement. Let us understand this definition with this flow diagram. If A is greater than B, then true path is executed, else false path is executed. Statement coverage always checks for true path. That's what this statement explains. Statement coverage is calculated in terms of percentage and it is expected to be 100%. The formula to calculate the same is number of executed statement divided by total number of statements multiplied by 100. Let us consider an example program to understand how this formula can be used to check statement coverage. In this program, I have numbered each line to identify easily. It reads A and B from standard input and checks whether A plus B, that is C, is greater than 41 or not. If it is greater than 41, then large C is printed, and finally the program ends at 6th statement. Consider two statements to test this program. When A equal to 2 and B equal to 3, first, second, third and fourth statements are executed, but not fifth because A plus B, that is 5, is not greater than 41, and program ends at 6th statement. Hence, statement coverage for first test case is 5 divided by 6 multiplied by 100, that is 83%. Consider second test case. In this case, first, second, third and fourth statements are executed. In fourth statement, A plus B, that is 45, is greater than 41, fifth also gets executed. Finally, program ends at 6th statement. Hence, statement coverage for second test case is 100%. Let us see pros and cons of statement coverage. Let us see the pros first. It verifies whether the written code is working as expected. It measures the quality of the code written. It checks the flow of different paths in the program, and it also ensures that whether those paths are tested or not. Let us see the disadvantages. It cannot test the false conditions. It does not report that whether the loop reaches its termination condition. It does not understand the logical operators. In order to overcome these disadvantages, branch coverage comes into picture. Unlike statement coverage, branch coverage covers all true and false conditions. It can be calculated as number of decision outcomes divided by total number of decision outcomes multiplied by 100. Like statement coverage, branch coverage is calculated in terms of percentage and it is expected to be 100%. Let us consider this representation of a program to understand branch coverage. This program does three operations: add, subtract and exit, and there is error handling criteria. In order to test this piece of code completely, 4 test cases are required, one for each operation and another to check error handling. Let us see the next test case design technique, that is condition coverage. Condition coverage combines statement coverage, false condition and other conditions in detail. Let us see its importance with an example. Consider a function which accepts a and b as input and returns boolean value depending upon if a is greater than 5 and b is less than 15. This kind of statement is not validated either by statement coverage or by branch coverage. Hence, conditions coverage is very important to validate very minute levels of statements. Let us see next test case design technique, path coverage. Path coverage refers to designing test cases such that all linearly independent paths in the program are executed at least once. A linearly independent path can be defined in terms of what is called a control flow graph of an application. Let us see few control flow graph for if construct, until construct, while construct. Now let us see the next test case design technique, that is cyclomatic complexity. The cyclomatic complexity of a section of source code is the number of linearly independent paths within it. The complexity m is defined as m equal to e minus n plus 2, where e is the number of edges of the graph and n is the number of nodes of the graph. Let us understand cyclomatic complexity with this flow diagram. This graph has 9 edges: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 8 nodes: 1, 2, 3, 4, 5, 6, 7 and 8. One connecting component. Hence, the cyclomatic complexity of the program is 9 minus 8 plus 2, that is 3. That's all for test case design techniques for white box testing. Let me quickly summarize today's topic which we have seen. First we have seen statement coverage, then branch coverage, conditional coverage, path coverage and finally cyclomatic complexity. Thank you for watching this video. In the next session, I will be explaining about test case design techniques for black box testing, which will cover equivalent partition, boundary value analysis, decision table, input-output domain testing, comparison testing, orthogonal array and use case testing. Kindly provide your valuable feedback as a comment and let us know if any topic you want us to make video of, or any issue which you are facing in your project. Please email to us at feedback@kpro.co.in. Thank you very much. Let's keep learning.